I just mentioned that you'll have exponential growth if B is positive, but I also wanted to mention it'll be more steep. So the faster the growth will occur if B gets bigger and bigger. So if you have an exponential with base 2, then it's going to grow exponentially really fast. But then when that base gets even larger, like 4 to the x or 7 to the x, this compares the growth of each of those. So when you think about these values at 2, this would be 2 squared. So 2 to the 2 is 4. So you can see that this intersects for y equal 4, but you can't even see it for the other two. And that is because 4 squared is 16. So this would go to the point 2, correspond to the point 216. And 7 squared is 49. And so 2 comma 49 would be the ordered pair for this one. They have very different values just for x equals 2. So you can only imagine what would happen when we let x equal go to something like 100. And those are kind of the ideas that we're trying to wrap our minds around in this assignment. There are 3 stories that you need to read for your homework. They are on pages 473 through 496, and you can get to those through the e-text that I walked you through before. So please read the book. You need to read these 4 pages in your textbook in order to do a few of the homework problems. And the homework problems are really, it's kind of reading retention, less math than just making sure you've read the story. I'm going to summarize, but not give it its due justice right now. I'm going to try to summarize the story a bit. There is a story that will relate to, I want to say 4 to 5 of your homework problems about bacteria. One of the stories starts where you place a single bacterium in a bottle. It sounds harmless. You place it in there at 11 a.m. But by 11:01, after 1 minute, the bacteria has divided into 2 bacteria. So in 1 minute, it has doubled. By 11:02, both of these bacteria have each divided into 4 bacteria. By 11:03, you now have 8. After 3 minutes, we've gone from 1 bacterium to 8 bacteria, and so on. So suppose the bacteria continue to double every minute for a full hour. And by 1 hour, the entire bottle is full. 60 minutes have passed. And so we know how many bacteria are in there. We know that there are 2 to the 60 bacteria in the bottle. And they have filled the bottle completely in 1 hour, in 60 minutes. The story continues to say we have a disaster ahead of us, and we want to talk about that a little bit more right now. So I'm not going to get into every single reason that we have a disaster on our hands, but most of your homework will ask you about why it's going to be a disaster. And the book will talk through a little bit more of that in a fun way. So the next question I'm going to ask, so a question from the bacteria story. So after 1 full hour, the bottle was completely full. So by noon, when was the bottle half full? 11:59. Yes, it was half full 1 minute before it was full. Why? Because it's doubling every minute. So if it's full at noon, then you're just going to go back 1 minute to consider when it was half full. Your homework is going to ask you several questions that are essentially just like this, trying to make sure that you understand the idea. And it's common that people will miss this problem because they tend to go back half an hour to 11:30. And our minds are just kind of playing with us there. Drawing pictures out helps a little bit, but yeah, 11:59 is the correct response here. The bottle was half full 1 minute before it filled the bottle, and the reason is because it's doubling every minute. How many bottles would the bacteria fill at the end of the second hour? I do want you to think about this for a minute. So we just filled 1 bottle at 1 hour. How many bottles would the bacteria fill at the end of second hour? At noon, we filled one entire bottle. So by 12:01, we have filled two. Yeah, Paige, thank you. By 12:02, we have filled four bottles. By 12:03, we have filled. So this is no longer just thinking about tiny bacteria in a bottle. We're filling entire bottles. So this is growing exponentially. By the end of 2 hours, you will have filled 2 to the 60 bottles because that's doubling, and you started with one bottle. Then every minute you'll double that value. So 2 to the 60 bottles. Now, some of your calculators, if you want to try this, go ahead and pull out your calculator and type in 2 to the 60. I have a feeling some of your calculators won't return a value. What I want you to understand from that is this is huge. This is massive. 1.15 times 10 to the 18 is larger than any of the, so we've talked about big numbers in this class. That's, if you'll remember, a million was 6, so 10 to the 6, so 1 with 6 zeros. And then we talked about a billion, a trillion. This is far over that. So this is only with 2 hours of one little harmless bacteria, and we already have this type of growth. This type of growth is called exponential growth. In your homework, they're going to ask a few different questions, and they might change the wording occasionally, but it is about this bacteria story, or you'll hear about a rice scenario, or you'll rice and chessboard, because that's another classic story. And then you'll also hear about exponential growth leads to repeated doublings. We were just talking about the doubling function. With each doubling, the amount of increase is equal to the sum of preceding doublings. So the reason I'm saying this is because there's a homework problem in 8A where they will ask how much you have after, say, 2 hours, and then they will ask how much overall there was. So I believe this is with the rice and the checkerboard. And to do that, you add up all of those values. So you'll keep that in mind for that problem. Exponential growth for the rice problem will lead to doublings. And then when you think about the total amount, you'll need to add up for each of those changes. Okay, something else that is in your homework, you'll have a multiple choice problem that is alluding to this. Exponential growth cannot continue indefinitely. You can see that this already got massive. This bacteria has already taken over the whole globe when we get to the order of 10 to the 18. So know that exponential growth cannot continue indefinitely, and then know that we were just talking about repeated doublings, and you will work with that in your homework.